Lesson 3, Linear Relations in Tables and Graphs. So we're going to start with example 1. You are installing an automatic watering system in a small greenhouse. You need to measure the maximum flow rate of water from the water supply. The rain barrel holds 340 liters. Just make a note of that. You empty the barrel, turn on the water supply fully, and note that it takes 16 minutes and 30 seconds to fill the barrel completely. Do you expect this to be linear? Now this will be a linear relation, and the way that you can tell it is that the water is coming in at a constant rate. And anytime you have a constant rate, it's going to be linear. That constant rate is called our slope. So we're going to graph this just to make sure. So first we'll start with our independent and our dependent variables. Independent is always going to be time. If time's an option, it is the independent. And that will be our x. Our dependent is our liters. And we're going to make that our y. So we're going to make a table of values quick. So we have our x and our y, our time, and our liters. Now we know that the rain barrel starts at 0 and 0. There's no water, and the time hasn't started yet. We know it finishes filling at 340 liters. And it takes 16.5 minutes, so we're going to put it as 16.5. Rather than put it in minutes, we're going to put it into seconds, we're going to put it into minutes. So we have 16.5 minutes. So we're going to make our x-axis going up by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We're going to go up by 20. So 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 40, 260, 280, 300, 20, 340, 360, 380. Okay, now we're going to find our slope. So we have 2 points, we can find our slope. So we have y2 minus y1 over x2 minus x1. We have 340 minus 0 over 16.5 minus 0. You get 340 divided by 16.5. So our m, I'm running out of space, so I'm just going to erase. Our m is equal to 20.61 liters per minute. And our y and our x-intercept, y-intercept and x-intercept is at 0 and 0. It's crossing the line right here at 0 and 0. That's our first point. So I also want you to make sure you label this time in minutes and depth in liters. So we're going to graph. We have our point at 0 and 0. We have our point at 16 and 340, which I think is right there. Sixteen and a half. Oops. 16 and a half. Right here. And then all you're going to do is you're going to connect the dots with a straight edge, unlike what I just did. So that's what your graph should look like. Because our graph starts at 0 and 0, this is called a direct linear relation. So what that means is it's a linear relation and it goes through the point 0 and 0. Okay, example 2. Joseph is moving to St. Paul, Alberta to attend college. He has rented a moving van to move his belongings. The van costs $20.95 and then 69 cents per kilometer. Graph the relation and show if it's linear or not. So our cost is our dependent. It depends on how many kilometers we go, which is our independent. At 0 kilometers, you're spending $20.95. And then every kilometer past that, you add 69 cents. So add 69 cents to $20.95 and you should get $21.64. Plus another 69 cents is $22.33. The next is $23.02. And $23.71. So we're going up by 0.69, and this side we're going up by 1. So our slope is 0.69 over 1. So we're going to graph this. Along the x-axis, we're going to go up by 1s every 2, just to use as much of the graph as we can. And because we don't have a lot of room on the graph, when we go up and down, we're going to go up. We're going to do a little squiggly line here. We're going to start with 20. And we're going to go up by 0.5s. So 20.5, 21. 21.5, 22. 22.5, 23. 24. 25. And now we're going to graph. So at 0, it's at $20.95, so right here. So we can automatically see that our y-intercept is $20.95. So 0, $20.95. And then we're going to go 1 and $21.64, somewhere in here. 2 and $22.33. Oops. 3 and $23.02, right above the line there, and 4 and $23.71. And you just connect your dots with a straight edge, and we can continue this on because we don't know how many kilometers he's driving. So this is a linear relation, and we already knew it was because it was going up by a constant amount. Because we did not start at the origin, we started at $20.95. This is called a partial linear relation. So it's not going through 0 and 0. That is why it's partial. Example 3. Francesca has $200 to spend on food during the holidays. She spends $18 on average each day. Graph the relation and show if it's linear or not. So independent is going to be the number of days that she's on holiday, and dependent is the cost. Money is almost always dependent. How much money she has depends on, I guess it's not cost. How much money depends on how long she's been on vacation. So, this will be days, and this will be how much money she has left. So, no days into her vacation, she's got $200. That's what she starts with. After 1 day, she spent about $18, so she has $182. After 2 days, minus 18 more dollars, and it's $164. Also, this is fairly unreasonable because there's no way you're spending $18 a day on food anywhere. You need to budget a little bit higher for food. Anyways, 3 would be 146. 4 is 128. And let's stop at 5, and that's 110. So as you can see, this is going down by negative 18. And this is going up by plus 1. So our m, our slope, is negative 18 over 1. And you can tell your y-intercept right away because it's right here. 0 and 200. Now we're going to graph it, and we're going to go up by ones. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And we're going to go up and down by 20s. So 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, and let's go to 220. So now we're going to graph. We're starting here at 0 and 200, 1 and 182, 2 and 164. That first spot I made was a mistake, and I'm making it worse. 3 and 128. 146. I don't know where I got that number. Oh, it's the next one. 4. Killing it on this video. 5 and 110. So there's our line, and we're going to extend it because I think the most interesting thing about this question and what we'd really be wondering is, when does she run out of money? So if you extend your line down, it looks like it's somewhere after 11 days. My line's not quite straight because I can't use that ruler on the iPad. So that is your linear relation.